Hello everyone, I am Daman Singh, an MS research student at IIT Delhi, and I'll be presenting a work titled FairAssign, Stochastically Fair Driver Assignment in Gig Delivery Platforms. Gig delivery platforms are online platforms that provide online ordering and delivery facilities. There exist a variety of these platforms spanning food delivery, quick commerce, and medicine delivery, among others. Gig delivery drivers are personnel hired by these platforms to deliver the concerned goods. Naturally, they form a crucial part of the delivery ecosystem, and millions of drivers are currently engaged with these platforms across the globe. Despite being an indispensable part of the delivery ecosystem, the drivers are often deprived of employment benefits, have poor working conditions, and earn inadequate wages, due to which they have to go on repeated strikes to demand a fair wage. To address such concerns, there have been recent works, particularly in the domain of food delivery. One such work is FairFoodie. They analyzed a real-world food delivery dataset and found that on top of lower incomes, there exists high variability in the incomes earned by the different drivers. Specifically, they found that 20% of the drivers earn more than 60% of the total income, whilst the 60% bottom earners don't even earn 20% of the total income. They also found that the primary reason of this income disparity is the driver's working area, and surprisingly, not their active hours or the operational periods. So they do away with the working areas and try to achieve a more equitable income distribution using reasonable heuristics on order level assignments. Another work is gigs with guarantees. Like Fairfoodie, they also disregard working areas and try to guarantee a fair wage or a minimum wage based on some heuristics. But none of these works actually consider the opinions of the stakeholders being helped, that is, the drivers. In absence of consultation with the drivers, these solutions pose a risk of techno-solutionism. For example, Fairfoodie might push the drivers to faraway zones or faraway delivery areas, while gigs with guarantees might drop the drivers off the system when the demand is low. Both of these solutions would be undesirable by the drivers. Therefore, as a first contribution, we reach out to the drivers to know their perception of the current gig delivery scenario. We conduct in-person interviews with 30 delivery drivers from two major Indian cities, spanning food delivery and e-commerce delivery domains. Our first finding was that the platforms divide a city into delivery zones, and each driver is assigned a fixed zone when the driver onboards the platform. Second, we found that a driver would like to or would prefer to be assigned to nearby zones and areas for delivery, and they show a reluctance to visit faraway unknown zones. Next, this suggests that there exists a notion of spatial stability within the drivers. Next, we found that the drivers' notion of a fair income distribution are more locally rooted into their neighborhoods. Based on the interviews, we see that zoning is preferred by the platforms, and most drivers agree with zoning as long as they are assigned to nearby zones. We suspect that a primary cause of or a major cause of income disparity in such a scenario would be the static assignment of the drivers to the delivery zones. Note that this is Note that this assumption is consistent with the observations made by Fairfoodie on the real-world food delivery dataset that we saw earlier. Therefore, we propose a dynamic assignment of drivers to delivery zones. We hypothesize that a dynamic assignment of drivers to nearby delivery zones can lead to a reduction in the spatial inequality in the incomes seen by the drivers. We introduce a two-stage assignment framework where in the first phase we find a probability distribution over the set of zones for each driver. For this purpose, we formulate an LP with two desirable constraints. The first is a fairness constraint based on the notion of individual fairness to ensure that nearby drivers are assigned to similar zones. Second are the capacity constraints to capture the maximum and minimum delivery driver requirements of a particular zone. In the second stage, we sample from these distributions on each day to know the zone assignments on that day. Note that independent sampling in this case might lead to a violation of the capacity constraints. So in order to preserve these capacity constraints, we use the randomized dependent rounding algorithm. For the purpose of experimentation, our first focus is on a real-world food delivery dataset, which has 6 days of food delivery data spanning 3 major Indian cities. We obtained this dataset by contacting the authors of Fair Foodie. This dataset includes elaborate information about the orders, road networks, and other required metadata. We evaluate on multiple fairness evaluation metrics and similarity measures. The results corresponding to spatial inequality index and physical distance as a similarity measure are shown here. We see that FairAssign is able to achieve better cost fairness trade-off as compared to multiple static and dynamic assignment baselines. Similar results are obtained for other fairness evaluation metrics such as Gini index and income gap, and also other similarity measures. Next, we consider a semi-synthetic Brazilian e-commerce dataset. We experiment with 30 days of data pertaining to 3 major cities. Here also we see that FairAssign is able to strike better cost fairness trade-off as compared to multiple other baselines. In conclusion, we have proposed a stochastically fair dynamic assignment framework for assigning delivery drivers to delivery zone. We have done this while considering the opinions of the drivers into the algorithmic design. We consider 2 different datasets for experimentation spanning food delivery and e-commerce delivery, and we have evaluated on multiple fairness evaluation metrics. And we see that FairAssign is able to strike a better cost fairness trade-off as compared to multiple other static and dynamic assignment baselines. Thank you for your attention.